Okay, so let us have a look at what some of the ideas that we covered in the last lesson. So the one thing that came up a lot was if we have circles and we have radii, we often have these isosceles triangles. So whenever we have circle geometry, whenever we have equal, well, radii are always equal. Basically, we're going to get these pairs of isosceles triangles. And so you need to be aware of that because they will come up. And even if you know those two angles, you can always work out what this angle is by going 180 minus those two angles there. Then probably the most time in the last lesson was spent on this theorem which talks about the angle at the center and the angle at the circumference. And what we noticed was that it doesn't really matter where the angle is, but the angle at the center, if you're using an arc as the starting point or a chord, and you make an angle at the center and you make an angle at the circumference, the angle at the center is always double. And sometimes it looks like an arrowhead, sometimes it looks like a bow tie, but the relationship is still going to be the same. It's going to be double at the center compared to the circumference. And even if I change this, well, let's say I change that down to 60, you'll see that that's 30. So that's a definite like embedded relationship. There's a theorem that deals with that, and you actually learn how to prove it. And then the other shape that goes like this is still the angle at the center is twice the angle at the circumference, but the difference is the angle at the center is being made with the major arc. So the major arc, if you imagine maybe I can even draw it before you. So like you imagine, oh, I can even move that. Who knew? If you imagine the major arc going all the way around here and then making an angle at the center, that angle is going to be that 198.5. Okay. So it's going to be that one there. But then what is the angle at the circumference? It's going to be the red one here. It just looks a bit different because of using the major arc. And then the other thing that we did in the previous lesson was terminology to do with circles. So let me quickly just talk about that. So we spoke about something like that. That is called a tangent. A finger touches a circle in one place. We spoke about the center of a circle, and if you have a line coming from one side to the other going through the center, that is called the diameter. If you've just got 2 points on the circumference and you connect them with a straight line, that is called a chord. And then we also spoke about a couple of things, but the other important one was something called a cyclic quad. And a cyclic quad is a quadrilateral where all 4 vertices fall on the circumference of a circle. So that's a little recap of what we did in the last lesson. Some just general, we basically dealt with triangles inside circles as well. So let's start with a little recap or a little couple of questions just to get the brain flowing. So let's start with this one. Can you tell me what the size of angle X is in this drawing? What is the size of angle X? Using the theorem that we have learned about in the previous lesson. If you're unsure or if it's your first lesson today, I will give you some help. Here is the arc on which the angles are based, and the angle at the center is here, and the angle at the circumference is there. So you do know that that is 120. Yes, X is 120. Okay. Let's now go. Can you find the size of angle X in this one, in 2.2? What do you think that is? So again, you can see that arc that's going here, and then the angle at the center is the 150, but the angle at the circumference is going to be half that, which is 75. So x will be 75. Now, there is another angle that they want to know, which is hiding down here. Can you find me the size of angle y? Sapang, let's see. I agree with you, Sapang. You are on the money. Okay, there's actually two ways you can do this. The one way is to realize that the angle O2, which goes around the outside here, is going to be 210, and that is the angle at the center, and then the angle at the circumference is just this one here, in which case y is 105. For those who are doing circle geometry already in class, you may know about the theorem about cyclic quads. And in a cyclic quad, this is, in fact, this ABCD is a cyclic quad. You can see that all the vertices are on the circumference of the circle. In a cyclic quad, opposite angles are supplementary, or another way of saying that is they add up to 180. So if you know that this one is 75, well, then this one must be 105. But that is a theorem we're going to cover next week, which deals with cyclic quads. Okay. All right. Let us continue on. Let us look at something like this, which is a little bit harder. Let us focus in on question 10. So, a little bit harder, but that's good. That's why we're here. Can you find me the size of angle D? Can you find me the size of angle D? And then after that, we are going to try and find the size of angle C. Oh, it'll change at Sepang. For example, here, if you look at this one over here, the angle at the center here is 88, which means the reflex angle here would be 360 minus 88, which would be, what would that be? 28, 280, 272. In this one, this would be 272. Now, it's not relevant, but it depends. The angle can change. We just know that if it goes the whole way around, it's 360. Hmm. Okay. So what do we think D is going to be? Okay, I'll give you a hint. You know that this angle here, okay, is the angle at the center, but this angle over here is the angle at the circumference. So what we're going to say is that D is equal to 44 degrees, and the official reason would be angle at center is twice angle at circumference. Now, if we've got this is 44, how are we going to get C? I do notice something, though. Who wants to give us a tip? There's something about the pink which is catching my eye. So what is special about the two pink lines? Sange, you are quite correct. These are radii. Or, and so these two must be equal in length. Perhaps that can help us. Sange, can you give us a tip or point us in the right direction? How could that help us find C? I think this angle must be C as well. Yeah, so C is going to be 180 minus 88 divided by 2, because there's two of those. And the reasons, there's actually two reasons that you're using there. Well, let's have a look. Are you really? Yeah, you are. You're using the reason that the sum of angles in a triangle. So you're using the fact that they add up to 180, and you're also using the reason angles opposite equal sides. So you know that this C over here, which is opposite the red, and this over here are the same. And so angles opposite equal sides. So what is it going to be? What is C going to be? 92 divided by 2 is what? What are we going to get? I get, in my head anyway, I get 46. Would you agree? Oh, Ronnie agrees with me. Fantastic. So does Sange. So does Sapang. Well, I think then we are off to the races. All right, everyone. Well, I don't think that was that easy, to be honest. So let's go and do another one that's somewhat like that. Let's do number 12. Can you find the size of angle G? And then after finding the size of angle G, can you find the size of angle H? Okay. So what do we think G is going to be? Let's have a look. What are the important? I can see this is kind of important. Oh, that's too thick, isn't it? So that is that. And this one is the angle at the circumference. So for me, I would say that G is 76 degrees and angle at center equals twice angle at circumference. So this is 76 degrees. But now, what is H going to be? And what ideas, what facts about circles and triangles are we going to use to help us get there? Who feels like they can offer something to the group? So Ronnie has suggested, let's have a look, Ronnie. So I think the radii, you know what? It's the same idea again. So when I want to work out what H is, I am going to say 180 minus 76, and then I'm dividing it by 2. And the reasons are the sum of angles in a triangle. And we could also say, instead of the longer one, we could actually just say radii. It's a nice quick one. So radii. And what is that going to be equal to? 4 left over, 104 divided by 2 it's going to give me 52. And so then I know that H is 52. Give me a score out of 10 about how you're feeling about these questions. 10 is perfect. 5 is sort of in the middle. 0 is no understanding at all. Let me know if you how are you feeling? Okay, so we're going to keep practicing until we feel comfortable. But I think we're doing okay for now. Let's do this one. So can you do 11? So for number 11, you are going to help me try and find what is E and what is E and what is F. And it's the same ideas. There's a couple of ways you could do this. It's not the only way you could do this, but there's a couple of ways you could do this. Would you guys start with E or with F? Where would you start? F. Yeah, because you can kind of see these are radii, hey? Yeah. I would probably start there too. Okay, Tsapang agrees. So does Siamtanda. Okay, well, I think the reasons we've been using so far would work quite well here, where you go 180 minus 98 divided by 2. And the reason you are using are radii and sum of angles in a triangle. And what do you get for the value of F? What do you get for the value of F? 82 divided by 2, which should be 41. Okay, so we get 41. So that's good. So we've got a 41 down here. And I suppose if it's helpful, we get a 41 up there. What do we think the connection to E is going to be? What do we think the connection to E is going to be? I'll give you a little helping hand. What do we think the connection to E is going to be? Who can spot that connection? So E is actually not 41. Can you see the base, we'll call it the base AC, the chord AC, which is helping me here? I think the angle at the center, oh, I made that far too thick, so let me try again. If you imagine this as getting the angle at the center is 98, the angle at the circumference is going to be E. And so all we're going to say is that E is equal to 98 divided by 2. And what is that going to be? It's going to be 49. And the reason is angle at center is twice angle at circumference. So that was, again, one of those ones where it's hiding, but that's why we're doing this, right? We're like building our visual fluency for this. Now, the other ones aren't too bad. So I think that is fine for that one, but I'll give a moment. Are there any questions or comments about these questions we've been doing before I move on a little bit? Does anybody want to ask a question? You just raise your hand and then you can ask an audio question or you can ask me to clarify something. Otherwise, I will move on. Okay. All right, so I'm going to assume that, yeah, like, we're in the process. Now, there's another fact about circles that you guys need to be exposed to. And these first two lessons are all about circles and the center of the circles and what facts go with, circles in the center of a circle. So let's have a look. Okay, so if we have the diameter of a circle, and the diameter is just a chord that goes to the middle, look at what happens when I move the angle at the circumference. What do you notice about the angle at the circumference when you use the diameter as the base to subtend an angle? What do you notice? It always seems to stay fixed at 90. Which is a little bit odd when you think about it. Well, it's not actually that odd, but it's a little bit surprising. And I'll show you why this is. So do you guys know what is the angle of a straight line angle? So say I've got the diameter, right? What is going to be the size of the angle on the diameter? What is going to be the size of the angle on a straight line or the angle on a diameter? It's going to be 180. Okay, but isn't our diameter just the angle at the center? Now let's take that diameter and let's subtend an angle at the circumference. What is half the angle, or what's half of 180? It's going to be 90. And that's why it doesn't really matter where the thing is drawn, because it's always going to be half of the angle at the center. And so it forces this to be 90 wherever it goes. So the name for this theorem is angle in semicircle. Angle in semicircle. And basically, we can use it as a fact going forward. So let's see a question that relies on this. Let's have a look at a question that uses this. So you are given a circle with a diameter, and you are asked to find the size of angle P. Which of these four options do you think is correct? Well, you know that the angle over here must be 90 based on the idea that I just got. We know that's 18. So then this has to just be, P has to be 180 minus 90 minus 18, which is 72, which is D. Fantastic. Okay, so you've got this basic idea. So let's have a look at another question which maybe uses this idea. So find me the size of angle A and angle B in this question. What is the size of angle A and what is the size of angle B using what you've learned about circles, facts about the circles in the center? Okay, so A must be 90, and using the official reasons, which I'll share with you later, but angle in semicircle, and then the B would have to be 180 minus 90 minus 55, which would be what? 35. And that would just be sum of angles. Okay. So let us switch back. Why did it do that? Okay, there we go. I'm back. Let's do one more before we have a break. Can you find me the size of angle A, angle C, and angle B? Can you try and find those, and then we're going to take a break? What do we think? Where would we start? Which one would we do first? I think A is the easiest one to do first, huh? If we look at this. So A would equal what? Yeah. A is 90. So that would be angle in semicircle. What would I get next? So I think C would be the next one because you've got a triangle. So C would be 180 minus 90 minus 62, which would be 28. And it would just be sum of angles in triangle. So that would be 28. And then what about B? What about B? What would that be? Well, this is also going to have to be 90, isn't it? So then B would just be 180 minus 90 minus 32. And so B would be 58. And that would just be sum of angles in a triangle. Okay, give me a score to 10 about how you're feeling about the content about circles and their center and using basic facts or theorems to solve for unknowns. 10 is perfect, 5 is sort of in the middle, 0 is nothing. Let me know in the chat what you feel is how things are going for you. Okay, awesome. Okay, well, in order to get the most out of the lesson, we want to make sure that we take a break. And so if you could just join me, turn on your cameras, and just join me in standing up for a second. And we're just going to relax a little bit. So we're going to stand up straight, and we're going to roll our shoulders back. So roll them back, roll them forward, Okay, so nice and loose. Arms out, nice and circly. Pull them backwards. Okay, then let's just flap them around a little bit. So we're just kind of getting any tension out of our bodies. Shake your legs out. Same thing. If you tense, your brain is not going to be learning maths as well. So you want to tell your brain, no, I'm chilled, I'm relaxed, and then you'll be able to learn better. Okay, then let's do a tricep. Like this. Okay. And then let us do some jumping jacks. So the jumping jacks is just to get your blood flow pumping. And we know that if you've been sitting and you're feeling static and you're feeling tired, that you're yawning, jumping jacks will just go. And then your brain will be back awake. So in 3, 2, 1, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whoa, oh, I almost whacked something. 15. There we go. Okay. And then let me share the screen. Can you solve the Maths 24 puzzle for today? So who can solve the Maths 24 puzzle for today? So the red one is a 6, a 3, a 2, and a 3. Which one of those do you think is correct? Can you make 24 with any of these? Okay, so Ronnie has said, let's have a look. I think you're correct, Ronnie. 6 times 3 plus 3 times 2. That would be 18 plus 6, and that is 24. So Ronnie, that is your one. Well done. Can anybody do the blue one? Can anyone do the blue one? 8, 3, 3, 2. That's 2, 3 plus 2. 3 times 2 is 6. No. Ooh, okay. I get it. Can anyone do the blue one before I steal the thunder? So I was going to go 3 minus 2 is 1. And from there, what do I do? Yes. 8 times 3 times exactly. So Ronnie, you are definitely our Maths 24 champion for today. So that's it. Okay, I hope your brain is feeling like it's had a little holiday. We're going to do our last sort of 15 minutes or so, and let's keep swimming with this. All right, let's do one more of these. So can you find me the value of C, A, B, D, and E? See if you can do that. And you can pop your answers in the chat as we go. Okay, which one would you go for first? I feel like the A would be the easiest one. Yeah, agreed. What do we think A is? What do we think A is? Yeah, so because this has to be 90, because this whole thing has to be 90, because you've got this diameter here, this just has to be 90 minus 57, which is 33. So my A is going to be 33. Okay, where do we go next? Zadindal, where do you think we should go next? See, Tanda thinks B. I probably think B as well because I just spotted something. I spotted that what are these two green lines actually? They are radii. And so what you can do is you can just say that radii, or you could say angles opposite equal sides. Those would both be fine. So we now know that that is 33. And then I guess we would get E. What's E going to be? So Sange, I agree with you. It's going to be basically 180 minus 33 minus 33, which is 114. And that's sum of angles in a triangle. So we've got this as 114. Where are we going to go next? Cool. Yeah, D. And what geometric idea are you going to use for that? It's kind of going back to grade 9 and grade 8, I guess, but still works. It looks to me, if E is 114, then D are just a pair of angles on the straight line. So you go 118 minus 114, and what do we get? 66. Yep, Savang, I agree. So we'll go angles on a straight line. So that is going to be 66. And then the very last one is C. What is C going to be? What is C going to be? It has to be 57 because, again, you've got these. You'll notice that the triangles are different, but it's because they're isosceles. And I'm just going to say radii, and C is 57. Okay, so actually, as you get to know these facts and ideas, I'll even point something else out to you. Do you know what? We could have also used the theorem at the center is twice the angle of the circumference, just to show you. It was also hiding in this drawing. So here is a chord, and then the angle at the center. Oh, wait, it's a different color. Angle at the center would be that one. Angle at the circumference would be that one. So you would expect B to be half the size of D. And you'll see here that B is 33 and D is 66. So there was even another way that we could have done that, possibly. But that's fine. You know, that's always like that with geometry. All right, another new idea about circles and the center. And this one is a little bit of an odd one, but caught me by surprise once upon a time. So if you have a circle, and in that circle, you have what's called equal chords, right? So let's say you have that chord and that chord. And what makes them equal is they are the same length. If you now make an angle at the center to that chord, and you have another equal chord, and that one makes an angle at the center, those angles that you make at the center are actually going to be, but I've actually made it look, let me make it look a bit easier to see. If those angles basically, if the chords are the same, the angles at the center, subtended at the center, will be the same, which is a bit of a weird one. Also, if you have a circle and you have equal chords, so let's say you have an equal chord here and an equal chord here, and the way that you would show that they're equal is you would put little lines there. The angles at the circumference will also be equal. So if I have two equal chords, the angles at the circumference will be equal, or if I have two equal chords, the angles at the center will be equal. Now then they won't be the same. Like this could be 30 and 30, and then this could have been 60 and 60. But it's just a case of being aware of that. Now, earlier on, my little animated thing wasn't working. Maybe it'll work now. Let's see if it will work. No, it's not happy. Okay, so let me show you a question where we use this idea. What is the size of angle X going to be in this particular question if AB is equal to BC? Okay, so because these chords are the same, even though the angles are made in different places, because the chords are the same, and so we would just say X is 24, and the reason would be equal chords, equal angles. What is the size of angle X going to be in this one, in this next one? Okay, not very exciting, but it's important that you just see it at least once. X is 56, and you can see down here, here are the official reasons. So equal chords, equal angles, and X is 56. All right, so that is another idea that we have to bear in mind, but it's just, you'll see it in the practice questions there. Let's have a look at what's this. Oh, we've done that one already. Okay, then last thing for tonight. Let's have a look at this one. So this has also got to do with the center of a circle. All right, watch this. Now I am moving this chord all around the circle. The only thing that is fixed is that on this chord, there is a midpoint, okay? And that will always be at the midpoint. But what do you notice about if you go to the midpoint of a chord? So if you draw a line from the center to the midpoint of a chord, what do you notice about that? If I can move it around. So it's always, notice the numbers, they're always, the orange and the pink are the same. So angles will equal, or no, the angles actually, the 62.5 doesn't change. The length changes, but they're always halfway. I think the thing that stands out for me is that, and this is what the theorem is about, it says, if you have a chord and you have a center of the circle, if you draw a line from the center of the circle to the midpoint of a chord, that angle will always be 90 degrees. So whatever chord you draw, if you draw a line from the center to the midpoint of that chord, that line from the center will always be perpendicular to that chord. Okay, so that's called the midpoint. Sometimes they say line from center to midpoint chord, or they call it the midpoint chord theorem. And then the converse of this, which I'll go into maybe more detail, the converse of this is that if you've got a line from the center and you draw it perpendicular to the chord, so if you draw a line from the center and it's perpendicular to the chord, then that line from the center will always cut the chord in half. And that theorem is just called line from center perpendicular to chord. So that's, I don't want to go, it's just, I want to show you this in a question and then you'll be able to understand how we use it. Actually, let's not do that one. Let's do, wait. Where was my exam question that I put aside? Is it still here? Nope. No. Let me just kind of look and see if it was in the F class that I put it there. Oh, here it is. Okay. Let's finish with this question over here. This is from an old exam. Okay. It says, given a circle with center O, so given a circle with center O, and a chord AB, which is 16 centimeters in length. So this is the chord AB. D is the midpoint of AB. So there's D, it's the midpoint of AB. AO is 10 centimeters. Determine the length of OD. So I'm actually just going to do this for you because we're running out of time, and I'm just going to show you how we would use the theorem. So at the moment, since the line from the center goes to D and it's to the midpoint, we would say that OD is perpendicular to AB. And we will use the theorem which says line from center to midpoint of chord. So line from center to midpoint of chord. And then we know we've proved that this is at 90 degrees. Okay, now, what we also want to do is we want to say that we know that AD is equal to what? How big is AD going to be? AD is going to be, yeah, you're right, Silikani, we're on the right track. AB is going to be 8 centimeters because it's half of 16, and we were given AD is equal to DB. So we know this whole thing is 16. We know it's half. Okay, so then we know that this is 8. Can you work out what OD is for me? What thing do you know about right-angled triangles that can maybe help you get this one? Exactly, Pythagoras. Can you work out what OD is for me, Tsafang? And then I think we're going to call it a night for tonight. What do we get for that? So we would say, there's a couple, I mean, you can do it the long way or the short way. It just depends what version of Pythagoras you're using, but you're going to go 10 squared is 8 squared plus OD squared by Pythag. And then if you move things around, you're going to see that at 64, that's 100. So you get 36 is OD squared, which means OD is 6 centimeters. And that is that. Okay, so what have we done in the last two lessons? We've looked at basic terminology or words about the circle, and we've looked at some basic theorems that relate to the circle and the center, and information that we can get or we can solve for unknowns and reasons we can use. In the next two lessons next week, we are going to talk about cyclic quads. So quadrilaterals that have all their vertices on the circumference of the circle and some properties around that. And we're just going to keep going from there. What I'm going to do now is I'm going to put the link to this week's quiz in the chat. And can I suggest that you just go in there and do it now? I don't think it's going to take you very long to do, or not too long. And if you get started now, then you can just whack it and be done with this for the week. But yeah, that is it for today. And you can let me know in the chat, how did you find the lesson? Give it a score out of 10. Did you find like you felt like you understood everything? 0 if you didn't really understand anything, and 5 if you were somewhere in the middle. Okay. And it was just, we're still in that introductory phase where we're just getting used to circle geometry. But yeah, I enjoyed teaching you. I hope that you had a beneficial time learning, and I wish you all well for the week ahead. So goodbye to Amelia,